Centripetal and centrifugal force. What is the real difference between them? This might sound like a fundamental concept on the surface, but I have seen a lot of my friends really struggle to understand the difference between them. Like, not the difference in the vague sense, like centripetal acts inwards and centrifugal acts outward, but to understand in actual physical sense. Like, they used to solve countless problems interchangeably using both of them without regard to any reference frame they are solving it in. They used to get answers because both of these represent the same formula and they used to use it conveniently to fit whatever solution they are trying to get at. But I still believe understanding concepts behind physics intuitively really helps you to develop further. So, today we are going to deconstruct the whole difference between them, not just to solve problems but to understand it intuitively. So, what is the difference between centripetal and centrifugal force? So, in one word, centrifugal force is not real. So, what do we mean it's not real? It is a fictitious force, which means it is a mathematical construct we add to our equations. So, this is not a real force at all. This is not a physical phenomenon that is happening. Centripetal force is a physical phenomenon. This is what helps object to change its direction. Whereas centrifugal force is not at all a force. No fundamental force of universe contribute to centrifugal force because it's not a real force. It doesn't happen. So why do we talk about centrifugal force? Like, why do we even bother about it if it doesn't exist at all? So that is where I think the whole misconception regarding centrifugal versus centripetal arises. That is called pseudo force. Even pseudo force is a fundamental concept that I think a lot of them really struggle to understand it intuitively. So let us start by briefly defining what pseudo force is. So let us take a cabin and a block of mass m just beside the wall on a frictionless surface. So here we place a weighing machine. This weighing machine measures the normal reaction this wall exerts on the block. As we know, weighing machine doesn't directly compute the gravitational force that is acting on you. It just measures or scales the normal reaction you're exerting on it. So it can be used anywhere to measure the force. So I put a weighing machine here just beside the block to make sure the wall is in contact with the block. Okay, so we are an observer. This characterizes us. We are observing the whole cabin, block, and weighing machine system, and even we can observe the readings from weighing machine. So we are observing from a stationary point. So we are in a absolute frame of reference, or it can also be called inertial frame of reference. So so this is where we are not accelerating. So we might be just standing still or we might be moving with a steady velocity. So we are not in an accelerating frame. Then it is called absolute frame or inertial frame. So let's just say this cabin all of a sudden starts moving with an acceleration a. So then what happens? Then immediately the block also starts moving with an acceleration a with respect to us. Due to the normal reaction, this wall exerts on the block. So as usual, the wall pushes the block and block starts to move along with the cabin. So now this whole cabin moves with acceleration a and we are observing it from a stationary point. Now we want to validate the second law of motion. What is it? It's Newton's second law. So it just says that it just talks about the force balance around the body. So what we do is we draw a free body diagram for the mass, and this is the normal reaction that is exerted by the wall, and this is the acceleration obtained by the block due to the normal reaction. So what we do is we just balance the forces. So normal reaction is causing the mass to accelerate. This is second law of motion, and we are fine with it because we see it is getting easily validated, and we are very satisfied with the second law of motion. But the problem doesn't arise here. The problem arises when there is a person, say a second character sitting here, and he observes the whole thing from an inside perspective. So he doesn't know that the whole system is accelerating, and even he is accelerating along with the block. Let us just say the whole thing we are seeing is accelerating, but he doesn't know that he is accelerating. So what he sees is he observes the reading, and then he suddenly observes a reading in the weighing scale, and then he is just panicking. Why? Because there is a normal reaction acting on the block, but the block is not moving because with respect to him the block is stationary, and there is also no other force acting on the block. So he is like, wait a second, is the second law not functioning here? Is the universal law collapsing in this particular situation? So he is really panicking. So what he does is, okay, let me just first draw a free body diagram from my perspective. So he draws from his perspective. What happens? He has a massive block M. I am not mentioning vertical direction because, as we know, weight balances by the normal reaction from the floor in both the cases. So only considering horizontal forces, he sees a normal reaction N, and then he sees nothing else. He observes zero acceleration of the block, and he sees a normal reaction, no other force is acting on any other side, but the mass is at rest. So he then calls this person outside. He calls him and says, Newton's second law is actually failing, we cannot believe it. Then this guy who has a lot of belief on Newton's second law says that, bro, it's not correct, you're actually accelerating, I saw you. So you are in a non-inertial frame of reference. So non-inertial frame means you're an accelerating frame. So you cannot directly apply Newton's second law from your observations of forces and motion. So that is not possible. So then he asks him, so what, shall I then just neglect Newton's second law? He says, you don't need to do that. You can just add a pseudo force or a fictitious force. That is where pseudo force arises. So it is a construct. So he says, you just add a force which is equal to the mass of your observing block and the acceleration you are moving with, which is a, because he's seeing that he's moving with an acceleration a. So mass into a. So then he starts to balance the forces. Normal reaction minus mass into acceleration is equal to 0. So normal reaction is equal to mass into acceleration. So now he added a fictitious force to balance his second law of motion, and then he validated his equation from the absolute frame, and then he is fine with it. So now he is happy with Newton's second law, but to validate the Newton's second law he had to add a pseudo force to it. So this is where pseudo force arrived from. So it is a mathematical construct we added to validate Newton's second law in a non-inertial frame. So this is a really crucial thing to observe. Like when you're accelerating, or that can be called as a non-inertial frame, you cannot directly apply Newton's second law. You have to add a fictitious force, that is pseudo force. So this is where the whole thing arises from. Now, throughout the whole discussion, we didn't yet arrive at centripetal or centrifugal force. So let's just start talking about it. So what is a centripetal force? I just want to give a brief talk about it. Let's just say a blob of mass m is rotating, orbiting around this center with distance r with a constant speed. So it's a uniform circular motion. So it's moving with a constant speed, it's doing the circles. But as we can see, its velocity is not constant because here it is in this way, but at this point, this blob can be moving in this direction. As we can see, the velocities of both of them are not same because the directions are different. As we know from the fundamentals of vectors, if the directions are different, the vectors are definitely different. And because the velocity is changing, there must be some acceleration that is responsible for it. And that acceleration is called centripetal acceleration. That can be computed with v square by r. R is the radius of curvature. And this can be derived directly by subtracting these two vectors, considering this angle as d theta, which is infinitely small. So then we can arrive at this formula. That derivation is not required here. So this is a centripetal acceleration. So this particular acceleration is existing anywhere the velocity is changing the direction. So this centripetal acceleration is responsible for any change in the motion, any change in direction of motion. Sorry. So if you observe a change in velocity, not just in circle, in any curved path, if you observe a change in direction of velocity, then there exists a centripetal acceleration acting perpendicularly towards the center of the curvature of that particular motion, and its magnitude is equal to v square by r. Now this is a centripetal acceleration. And what is centripetal force? Any force that causes centripetal acceleration is centripetal force. For example, this blob, how can it be orbiting around this point? Let's say we connected it with a string and then we are whirling around it. So string acts a force tension, say it is T. So tension is responsible for the blob to orbit around this point. So tension is the centripetal force here. Tension is equal to mv square by r. This is one example. There are like several examples. Like this is if this is Earth, Moon orbits around Earth, and what pulls Moon towards Earth? That is gravity. So in that case, gravity is the centripetal force. So any force that is responsible for change in direction of motion is a centripetal force. So any external force. So this force is a real force. Centripetal is a real force. That is not a fictitious force. So when you are in an absolute frame of reference, you should use centripetal force. So when you are in absolute frame of reference, let's say you are observing from Earth and Moon is orbiting around Earth, you just say Moon is orbiting with a velocity v, let's just say velocity v bar. So what you observe is there exists a gravitational force and hence the Moon is orbiting around Earth. So it is causing the centripetal acceleration. So gravity is equal to centripetal acceleration. That is how you balance the forces. This is one example. Now coming to centrifugal force. We explained pseudo force from the cabin example. Let's just take another thought experiment. Let's just say this is a cabin and the same man present here is standing here. He is standing on a elevator. Okay. Now this is not just a cabin, it's a satellite. It is orbiting around the Earth. Okay. And we are the observer standing on the Earth. And we can observe that this satellite is moving with a uniform speed, say v, around the Earth in a circular motion. So we can observe that there exists a gravitational pull on this man. We just want to study forces on this man. Let's just say this man. So we draw a free body diagram from our absolute frame of reference. So we see a gravitational force on this man, which is mg. This g might be way less than what we experience on surface, but definitely there is a gravitational pull. That is how satellites orbit around Earth. If we think about it, they do not have any thrusters. They just orbit because Earth provides the required centripetal acceleration. So let's just say a gravitational force of mg acts on this man. That is what we observe, and we see he's orbiting around Earth with speed v. So we see that he's accelerating towards Earth, because that is how acceleration works. Even though this man is not actually falling onto the Earth, just because his direction of velocity is changing, and the change in the direction is subtracting this velocity from this velocity results in an acceleration towards Earth. So that is what we observe. We observe a centripetal acceleration towards Earth, which is v square by r. So we then try to again validate Newton's second law, which is mg is equal to mv square by r, and we are sufficient with it. Our Newton laws is again intact. We are very happy with what we believe. But again, he observes the weighing machine. And what he observes, he sees 0 kg as reading. He feels weightless. And he panics again. And he calls us. He says, "Bro, I'm drawing myself a free body diagram again. And I can feel the force of gravity. I know that the field of gravity exists at me, but I feel no other force on me because my weighing machine is reading 0, which means I have no normal reaction, and I don't even experience any acceleration because he doesn't know that he is orbiting. So he doesn't feel any acceleration. He just says, I have a force acting on me, and that's it. And there is nothing to balance the force. And when he calls us and asks it, then he replies, the person on the absolute frame replies, "Bro, you are accelerating again. You are orbiting around Earth. I can see you. So you have an acceleration of centripetal acceleration, which is downwards towards Earth with v square by r. So what you have to do is, you have to again add a pseudo force with acceleration, the mass of this person into the acceleration he is experiencing, which is m into centripetal acceleration. So if you add the pseudo force on you again, then you can actually validate second law by balancing both the forces. That is what he tries again. mg minus mac. He tries to balance them because both of them are acting in the opposite direction, and he sees no acceleration on him. So again he writes the whole force balance equation, and then he validates with his friend's equation, if we abbreviate this. So now he is happy with the Newton's second law again. But what he sees is, he again added a pseudo force. Now this pseudo force is what we call centrifugal force. Even though this has a completely different name, centrifugal force is just like a pseudo force what we apply when we are in a non-inertial frame. But just in this case, we are in a rotating frame, which is also a non-inertial frame, because we are accelerating towards some center of curvature. So if you are actually making an observation from a rotational frame and you want to apply Newton's second law, then you have to add a pseudo force, and that pseudo force is centrifugal force. That's why it acts outwards of the center of curvature, because it is opposite to the centripetal acceleration.